Good morning all. So this is about a case study of a production tubing of an coal bed methane well. So most of you are not from oil and gas field. So giving you a brief introduction about what is an artificial lift for the wells that are not capable of producing by themselves because of less pressure. Artificial lifts are used. In one such well, here it is a sucker rod pump which consists of a sucker rod and a plunger assembly going inside a tubing, and due to its reciprocating motion, a suction force is developed which result in production from these such wells. So tubing in one such well got failed within an year. Here is the image of this tubing. So about the input data details and operational details, the material of construction of this tubing was API 5CT NATQ material. It got failed in approximately 5 months only. It failed around 296-meter depth, and at the depth where it failed, there was a deviation of around 20 to 25 degree. Apart from these are the operational data. The well operating pressure was 14 kHc. The temperature was around 40 to 50 degree. There was CO2 around 4%, but there was no observed H2S. Apart from that, sand was also observed in this tubing. So starting with the visual inspection, there was a longitudinal groove formed inside the tubing, and inside the groove there was a slit formation. There was a significant amount of corrosion product retrieved from this tubing. No external corrosion was observed. Apart from that, there was from the groove area there was no any significant corrosion at any other part of the tubing. We carry out the NDT using ultrasonic thickness gauging, and you can see that the reduction in thickness is observed only at the point 6, which is where the groove formed. About rest all the points, the thickness is almost the same. So to carry out whether it is material integrity is okay or not, we carry out the elemental composition, and it was found that the material was as per the specification of API 5CT NATQ. We carry out the tensile testing also, and it was also as per the specification. Hardness was also measured, and it was observed that the hardness of the tubing was around 25 HRC, while the sucker rod that was going inside the tubing has a hardness of 28 HRC. Corrosion product analysis was also carried out, and it was observed that the mainly corrosion product was iron oxide and chloride, which might be due to the interaction of produced water with the tubing. So the failed area was observed on the stereo microscope around 80x magnification, and we can see that we found wear marks and the corrosion pits. In the metallographic studies, the microstructure was found to be tempered martensite, which is typical of NATQ material, which are quenched material. So the failed area was also observed under scanning electron microscope, and it was observed again that there were longitudinal wear marks in the groove. Apart from that, corrosion product and pits were observed. In the EDA study, the elements that were observed were majorly oxygen, silicon and chloride. The silicon is present because there was present of sand inside it. The gravimetric method was used for calculating corrosion rate simulation experiment, where field conditions were simulated inside an autoclave, and it was found that the corrosion rate was slightly on the higher side, 32.5 mpy. So this is the mechanism of failure, that it was undergoing corrosion, and so the scale was formed, but due to the continuous rubbing of sucker rod with the tubing because of the well deviation, the corrosion product was removed from one side, and the cycle continues, and one such point the thickness got so significantly reduced that it could not sustain the pressure, and it failed in the form of a slit. Sand also played a crucial role in this wear phenomena. So to prevent this, we recommended to use tubing anchors which prevent the buckling of tubing in such divided wells. Also, the hardness of tubing and sucker rod should be considered, because the tubing should be harder rather than the sucker rod. In this case, the sucker rod was actually harder than the tubing. Also, in divided wells, sufficient number of molded guides should be placed at proper location, and to avoid sand, gravel pack or sand screens should be used. Thank you.